Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. This is Mehdi Al-Vali again. We'll start now with the first lecture online. And this lecture will talk about interpolation, Lagrange interpolation, and Newton interpolation, which is in chapter 8, and we are in week 8 as well. So this is here about interpolation from the lecture note. And in that case here, remember that we already had Lagrange interpolation. Today we will talk about Newton interpolation to make the lecture simple and not too long. So now here, interpolation means find a polynomial based on some given data, or we say given points. So if you have like 2 points here, which is like this one, clearly we have only straight line. But if you have 3 points, we can fit parabola 1, 2, 3. If you have 1, 2, 3, 4 points, it means you can fit a polynomial of degree 3, so and so on, continue. Now let's explain about the simplest one, 2 points, which you have exercised a lot in the past and in pre-calculus, also in secondary school. So now if you have 2 points like say x1 and x2 and y1 and i2, we would like to find the best linear interpolation, which means straight line. Just I like to remind you with this one, it can be written like this, which we will call also later on this formula called the Newton's formula, as we will see later on. But if I want to change this one, just take this one here, substitute with the slope, put it this way, and then rearrange this one here until you get it like this. So when you get it like this, this form called Lagrange interpolation. Lagrange interpolation means there is a function L1 times the value y1 plus L2 times y2, where L1 equal this here and L2 equal this value. We talk a lot about Lagrange interpolation. Now we would like to move, so just go and study it. We would like to move to Newton interpolation, which is here like now. So we'll continue like this. This is from the note, in fact. And here we are. Okay, this is a Newton interpolation. So as you see, which is in the book is section 8.2. So how do you write in Newton interpolation? Well, just this is the Newton interpolation. So the first part, like just before here, start with a constant plus constant times x minus 1, which means like straight line. If you want to make it a quadratic, you have to take the same but add this here to bracket, which may become a quadratic. Add more, the cubic, and so on until you reach this one, which is a polynomial of degree n. This is called interpolation. So it depends on the point you have. So clearly now, if you have 2 points, it means you have these 2 points. So you can fit only straight line. How to fit the straight line? So this one copy from here to here. So we have 2 unknowns, A1 and A2. How to find them? Well, the easiest way is to substitute x equal x1, so this will be 0. It means A1 equal y1 as it is here. Immediately, no need to write all of this here. And now we've found A1. How to find A2? Substitute any other value here. But we take the one which is available. x2 is available. Substitute x2 here, we get this one. Now, this is the only unknown is A2. Solve it, take this one left-hand side, divide by this, here is the solution. And then we know the answer as we know. So this is here, equation straight line, which we know it very well. This equal y1 plus the slope times x minus x1. Well, now we'll repeat again for 3 points. If we have 3 points here, they are. How can we make fit a quadratic or interpolate a quadratic functions? Just as before, this is the same as before here, straight line, but we add this quadratic term. When we add this one, we again would like to find the coefficient A1, A2, and A3. A1 and A2 as before we found them. No need, because if we put x equal x1, this will be 0, this will be 0, this A1 equal Y1. If you put X equal X2, this will be 0, it means here like before. So how to find A3? It means use the third point. Just put here X3. When you put X3 here, we will get this equations here. So that one here, when we have A3, then we solve it, it will be like this. So this is here the solution. This A2 is we found before. No need to repeat here. No need to, because already found them up there. So we can go here and just when you substitute here, solve it for A3, we'll get this one. So now we have found it. But we would like to write this one here in a special form to be how to generalize the idea. So when you go to next page, so that one here, A3, can be rearranged just like this. So that one here, A3. So what is the special things about it? Because special things is 3, and here we put X3 minus X1. So like before, and here what is the special things here? Well, this we know the slope, like Y2 minus Y1 divided by X2 minus X1, the slope, negative. What is it here? The same as this one, but add 1. So 2 becomes 3, 1 becomes 2, again here, 2 becomes 3, so easy to remember. So it means, if you want to find A4, it will be Y4 minus Y3 divided by X4 minus X3. Again here, the previous A3 divided by X4 minus X1, which is really true, as we will see now. If we go to next page, that's it. This is A3. And so on, so continue, as we say this, so we can guess this is A4, and continue in this way. So to understand this better, what we always need, just simple example. So now we'll take the very simple example here. So find Newton's interpolation using this data. How many data here? 1, 2, 3. It means we will get the quadratic. Clearly A1 equal Y1. Just copy from here. A2 is the slope, as before we know. This minus this, divided by this minus this, which is here. This is the answer. How to find A3? Take this one here, put it here. And this one here, 3 minus 2 in here in this one. Sorry, X3 minus X1. And then this is the new one. So Y3 minus Y2 divided by X3 minus X2. You get this one. Calculate this number carefully. You'll get A3. So now we know A1, we know A2, we know A3. So we know the interpolation polynomial, quadratic polynomial. So in that case here, this quadratic is next page. Here it is. Just now substitute the value of A1, it is here. Then substitute the value of A2, which is minus 1. A3 is here. Rearrange this one, we will get the answer. Well, this is the quadratic interpolations. Why do we need a quadratic interpolation? Because we would like to calculate something else. Like in this case, we don't know the function, but we know the function had 3 values, 3 data. So if you ask E, find the value of Y3, I don't know the value of Y3, but I know how to approximate the value by using this. So just means substitute this value here, we'll get this answer. So this one here, Y3 is, in fact, approximation. It is very important. Approximation by P3. Sometimes you know the function, but it's very complicated, so you can also approximate it by using this quadratic. So that's really in general. Now, how can I remember those formula? We would like to find a table which looks better and easier. So in that case here, we would write the slope here, which you know very well. For any value here, I, instead of writing 1, I write I. It means I plus 1, divided by xi plus 1. So this one, we write it like this, which is approximation of dx over dy. So delta x over delta y, which we used a lot in calculus and pre-calculus. But how to write this one in general? If you write derivative of the derivative, which means d 2 times d square y, it means, well, here it is just you put d, because look here, do you put d here? So it will be d here and d there, but here increase y by 1. So this was this. So how do you know this is 2? It means I plus 2. Here is 1, I plus 1. Here is 3, I plus 3, and so on, 2, 2. So in that case, we can generalize the idea A1 equal this, which is in fact d power 0, which means y1, and here d, this one yi, and then here d square, and so on. So in that case here, if you continue in this way, we obtain the following formula. So here we are. So to get a table, this is very nice table, easy to remember, because just we have the data, we put x here and all y here. Well, how to calculate this one? Of course, this formula you can memorize from before, but no need. This means the value here minus the value here. Divide by the value here minus the value here. And so you'll get this answer, which means, in fact, just if you go like, okay, just here I like to change this color. Okay, it means take this value, and something happened. I don't know what it is. All right, so we'll continue. Sorry about that. So this value here, if you want to continue this way, no problem. Now repeat again, same things here, this value minus this value. So it means just like this here, which means like this here, this value minus this value divided by this value minus this value. So we get the answer here. Repeat again here, this minus this will get this. So we know now 1, 2, 3, and continue. So we know this value. Now the idea, just repeat again to get these values. But here how to get here, again here, you go this way, and like this here. So this value minus this one, divide by x, this one x minus this one. And here same things again, and you will continue in this way. Repeat again here how to find this one, again same things. If you continue in this way, so just you can find those values here, because this is the last one finished. So it means we know these values now here in this line here like this. So now we know A1, which is here. We know A2, we know A3, we know A4. It means we can write the polynomial very easily. So this is just not numbers. So let's do this again, but with numbers now. So if you look at it here, just here as above. So we can see now, this is the numbers, as we say, this is x is given. We take it here, put it here. And this is the y. Y values, again, put it here. And just now, easy to work with number, easier than this one. This number minus this one, which is 2 minus 4, divided by 0 minus 2 is here. Calculate this, we'll get the answer minus 1. So this is the story is finished. So just repeat again, this minus this, divide by this minus this, we'll get this answer. Repeat again for these values, we get this answer. And also this answer, we finished here. Now here, I don't need to remember the formula. Just I go again, I say this number minus this number, which is 3 minus 1. Divide by which value here? As we say, this one, if you take it like, if you want to do it this way here, so this one here like this should go like this, and this one like this, and this one like this. If you continue in this way, so you obtain this number again, this number again, this number again. So it means you found, again, repeat again, you will find this number, repeat again, find this number. Repeat the last two numbers, this minus this, divide by like this minus this, you will find this number. So when you do this one here, it means the story is over. We finished this one. It means we know this. We know all this line here. It means we are ready to write the polynomial. So what is the polynomial like here? Here it is. So this one here, this gives you this answer. So this one here it will give you this one. No need to write this one here. You can immediately substitute here. This is A1. Here the polynomial. Just substitute here in this polynomial. We'll obtain next page. Okay, as it is, like this. So here we are, the polynomial of degree 3, 1, 2, 3, 4, degree 4. All right, so in that case, here is the polynomial. The story is over. So now we found polynomial interpolation of degree 4. Now, if you like to approximate the function at x equal 3, this is a 3 here, it means this y3 approximation of p3. This is a polynomial. So just substitute here. So here, I mean, substitution may take long if you don't do it carefully. But look here, this is 3 plus 2. We have calculated. I mean, assume it's not 3 plus 2, like something very long number, like 3.123 and 111. So here, this is repeated again here. Here it is. So that number, if we put it in a memory, multiply by 3. This time, this also keep it in memory, multiply here. So here it is, multiply by this. Somebody will say, oh, 3 minus is easy, no need. Yes, no need in this case, but in general, maybe this number might be very long. So again, we put this in memory, and all of this already calculated. And then multiply by this, and of course, while multiplying all this, please exercise this one and check whether it is correct or wrong. So it sounds here that this is P3 equal, but it's approximation of Y3, which means we know what is going on, and that's the example is finished. So we'll go to next page here, but seem to me no next page because today is the first lecture. I don't want to give a lot, just you can go and read what you have before about interpolation, and here today Newton's interpolation. We will meet you next time with chapter 11 and some other details, and also we'll give you the homework quiz or homework assignment. Okay, that's all. If you need any question, don't forget to write to me to my emails. Thank you for listening. Wassalamu alaikum.